Good morning, everyone, and welcome to this session on the technical framework called Socash. So obviously, for those who have already looked at the SOBOND framework presentation, it's the Socash names comes from a declination of the family of sustainable and open framework for blockchain smart contract. The idea of this Socash framework is to define the composition of a standard for cash account on chain by representing bank account into an IT infrastructure that is the blockchain. So if you have not yet watched the high-level presentation and the principle of Socash, so I invite you to look at the previous video. Otherwise, let's go and get started in trying to understand more technically what Socash is about. Something to precise, it's yet prototype version. It's a new type of approach that we have been designing. It has been technically tested through a prototype that is available on the GitHub repo. And we are trying to lay down the foundation of what we believe could be a future standard. But really what we would like as part of the CAS challenge, for instance, is to guide you and to help participants to understand what it is about and how it can be used and how it can be designed across the ecosystem and in order to form a proper DVP with the asset. So here we are on the Socash GitHub website. It's already public, so you can access it. We will put the link, obviously, on the description of the video. In this repository, there is this explanation on the page, which typically give some element that was already on the previous video, so I'm not going to replicate that. And there is a prototype application that we are going to show a little bit later without going into too much detail because it's a bit long, but I invite everybody to go into that. So what I want to focus on right now is to go in the framework itself and go on the technical discussion on what it means to use such a mechanism. So we have here some diagrams. Hopefully I will be able to display. And maybe I need to squeeze it a little bit so that it appears on a single page. So this sequence diagram show how what are the various elements and participants for executing a transfer, a simple transfer for the moment, not a DVP, between two bank accounts that are held by two different banks in the Socash model. So on the left side, you've got the sender. The sender is the one who owns the initial part of money and wants to send it to the beneficiary's account. So each of these blocks, sender account, sender bank, interbank debt, beneficiary's account, and beneficiary's bank and beneficiary's account are smart contracts that have a standard interface and that have the capacity to interface with each other within the realm of the blockchain execution. So let's try to get a little bit of understanding of the various blocks. The sender account is a very simple smart contract that is a kind of facade, if you want, to the back office module of the bank, the sender's bank. Okay. Then on the other side, we've got the same thing. We've got a beneficiary account, which is a facade, smart contract facade to the back office module of the beneficiary's bank. And in the middle, we've got some kind of generic smart contract that is there to record the debt between the bank. And we'll understand in a few minutes how those debts are forming. So let's say that the sender is willing to transfer some money to the beneficiary. He will submit a call to its own account, okay, its own smart contract that has been provided to him by its bank. It will send an instruction of transfer. In this instruction, it will give the address of the account of the beneficiary. The smart contract program of the sender's bank will perform a number of checks, and this is under the control of the bank to decide what kind of checks are necessary, and transmit that transfer instruction to the back office module. The reason the control are performed at the sender account is because it might be necessary to have some specific set of data specifically on that account and not necessarily on the back office module of the sender bank. Again, the back office module of the sender bank is a smart contract. It's sitting within the blockchain. So when the transfer instruction reaches the sender bank, there is additional control that can be performed, such as whether, obviously, the sender has sufficient balance and whether the beneficiary's bank is known. So to identify the beneficiary's bank, something that is not displayed here, but the sender's bank, knowing the beneficiary's account, because it's part of the instruction, can request the beneficiary's account to get the address of the smart contract that represents the beneficiary's bank. And therefore, the beneficiary's bank is available to the sender's bank and can check whether there is already a correspondent banking relationship between the sender's bank and the beneficiary's bank. The reason for verifying that there is a correspondent banking relationship is important because in this correspondent banking agreement between the two banks, there is the implication that they can accept a certain amount of debt between themselves. So the debt is forming as follows. The sender's bank is supposed to instruct the beneficiary's bank to credit the beneficiary account. But to do that, it has to first commit to pay the beneficiary's bank after the execution of the smart contract, because there is no common banking system between the banks. Here we are between the beneficiary, the client of the bank. So the sender's bank is going to record in the interbank smart contract that he will accept to have a debt with the beneficiary's bank. And then within the same transaction, send the transfer instruction to the beneficiary's bank. The beneficiary's bank implementation in the back office module, it's their own implementation. It doesn't have to be the same implementation as the sender's bank. And therefore, it will check whether the caller is a correspondent bank. It can check whether the target account is effectively an account on its system. It can check whether the debt that is already accrued with that other bank is not above a certain limit, and so on and so on and so forth. And if there is an acceptation, then it will record in the smart contract that is the interbank debt, it will accept that the debt typically. And by making that acceptation, it creates a commitment between the sender's bank and the beneficiary's bank that the sender's bank owe money to the beneficiary's bank. And when this debt has been accepted and it has worked, then obviously the beneficiary's bank can credit the account of the beneficiary. And this completes the transaction, the blockchain transaction, for transferring money atomically between the sender and the beneficiary. But then, after this transaction, there is a debt that has been created between the sender's bank and the beneficiary's bank. So in a normal situation, and there is several ways of doing that, but in a normal situation, the sender's bank can make a transfer in central bank money to the beneficiary's bank. And when this payment has been received by the beneficiary's bank, the beneficiary's bank can go and clear the debt in the interbank system, the interbank smart contract. Obviously, only the beneficiary's bank can clear the debt. Okay. So that's the high-level principle of this cooperation of smart contract with the sender's bank and the sender account smart contract being under the responsibility of the sender's bank, and the beneficiary's bank and the beneficiary's account being under the responsibility of the beneficiary's bank. The only common smart contract between everybody is the sender bank debt system that records the debt between each other. So if we look a little bit more now into the implementation of these elements, this interbank debt smart contract, we call that an IOU, which is the short for IOU. Okay, and this IOU interface is very much based on the ERC20 convention of interface. So it has an approve function that will typically make the sender allow the beneficiary's bank to create a debt on behalf of the sender. So obviously, this ERC20 type does not represent a real transfer of token. It represents the creation of debt. Okay, and there is this transfer from, which is the ERC20 standard function, and then there is the receive confirm, which is used by the beneficiary's bank to, or eventual third party, to clear a debt that has been formed by a previous call to transfer from. Between the back office module of the sender and the back office module of the beneficiary's bank, there is a need of agreeing of an API so that each other knows how to call the other back office module. So currently we've designed a single function that is enabling that instruction of transfer between banks that is called the interbank transfer. It's represented in an interface interbank backoffice. This interbank transfer will, for the moment, have very limited information, only the recipient account and the amount. Doesn't need more than that because it's expected to be called by the back office module of the sender's bank, and therefore the message from sender of this call is that address. And that normally is sufficient. And then we have a convention that we need to set up, an interface that we need to set up to represent the bank account of a user so that a user can have a standard way of interacting with its account. So here again, we are using the convention of the ERC20 because it's well known. And typically we took some conventions that the symbol of the ERC20 is the ISO currency. The name is the IBAN of the account. Obviously the decimal will represent the decimal, the number of decimals of the currency. It's an important field because if two banks represent the bank account of their client with different type of decimal, there is adjustment of call of values to be done and conversion to be done between the systems. There is the balance of the account and the balance of the account is typically the same, but balance of is the ERC20 standard. The transfer function is to send an instruction to the account to transfer from that account to someone else. The approve is to allow a third party to make the transfer on behalf of the owner of that account using the transfer from. And the allowance is to check what has been authorized by whom, exactly like in the ERC20 mechanism. Then the bank, with its internal system and with the team managing the bank account, needs to have, it's not mandatory to have that standard interface, but we are proposing that interface, that they can credit and debit money on the account of someone based on that API. So obviously to credit an account from money that is coming from an external account external to the blockchain, then the back office will credit the account specifying the amount. So that is the equivalent of minting in the world of the token. And similarly, when the back office wants to take money out of the account and take that money in an off-chain rail, then obviously it will debit the account, and that is the equivalent of burning token in a blockchain. So the rest of the documentation is the detail of the process. But we also wanted to display the possibility of breaking the flow of a transfer should there is a need of a back office intervention. And that's what we've implemented in the prototype also. So let's say that the control that are performed by the back office module on the blockchain shows that it's not possible to immediately execute the transfer. It could be because the balance is over a certain limit, and that would trigger the account to go under the threshold of authorized debit, or it could be because the account is under sanction or this kind of situation. So when the sender account send an instruction to the bank, so obviously we didn't represent here all the flow, but there is the sender that sends an instruction to the sender account, that sends an instruction to the sender bank module. Then the instruction is stored on the smart contract as a pending operation, and the back office team is notified by an event on the blockchain. Then they can operationally review and decide what decision to be taken, and then resume the transfer if necessary, which will trigger then the interbank transfer. And on the receiving side, the same can happen. Once the interbank transfer has been done, when the interbank transfer has been done here, then there is a set of control. The debt, if the transaction needs to be made in pause and can be accepted but should be made in pause, then we accept the debt. And then the transfer is put in pause before crediting the beneficiary's account. And possibly the money can be transferred back to the sender's bank if necessary. And when the decision is okay, then there is a resumption of the transfer and the credit of the account. So let's look now how it can be used in the context of a DVP. So this diagram displays an example on how the DVP can be implemented. So the DVP is a smart contract here. So we recognize the bond register smart contract, that is the Sobond smart contract. So the DVP here will be a satellite smart contract of the bond register. And I send you back to the video on the Sobond technical model. Then we've got the buyer account and the seller account. And this diagram does not show all the flows between the buyer account and the seller account, because these have been described earlier in this discussion. So the seller will, after the initiation of the DVP smart contract, that is not part of the discussion, will set in the DVP the account from which he wants to be to which he wants to be credited. Okay, so it's specifying typically its SSI. then he will accept the DVP, saying he agrees with the terms of this operation. Then the buyer, on his turn, will provide the account from which he wants to be debited. And it will approve the DVP. And because all the parameters are ready, this will, the approval, so the buyer will approve that the DVP smart contract can initiate a transfer on its behalf in its account. Okay. And then here we are ready to initiate the atomic DVP. So the buyer, who is the last to accept, by accepting the DVP, by signing, if you want, the contract, the DVP can, because it has been authorized just above, initiate the transfer of from the buyer account that he knows because it has been specified, that will trigger an interbank payment between the buyer and the seller. And within the same transaction, can initiate the transfer of the security in the bond register because the DVP has been authorized in the bond register as part of the satellite smart contract. So this DVP mechanism is the combination of being authorized to access the bond register on one side and being authorized to initiate a payment on behalf of the buyer. And because it's a unique transaction in a blockchain, it's either all or nothing. If it succeeds to make the payment, and if it succeeds to make the transfer in the bond register, then both will be stored in the blockchain. If any of these steps fails, then the full transaction is rolled back. All right, so now let's look at the final part of this video, which is presenting relatively simply the prototype that is available online. There is some documentation. So if you go to the top of the website, you've got the proto website. This prototype includes the source code of this prototype, but does not include the source code of the smart contract, and that's something to be completed at a later stage. Anyway, this prototype contains the compiled version of the smart contract, so it can actually be used and worked with. This prototype has been deployed as a GitHub page on the Socash github.io website. And there is some explanation, most of the explanation on how to use it in the environment. So the first thing to do is you open, so we're going to work obviously on the Carleano testnet. Again, Carleano is the testnet of the proof of climate awareness Ethereum compatible blockchain. And this link, which I'm going to open in a separate tab, brings you to a configuration page. In this configuration page, you will receive the address of the IOU smart contract, which is the smart contract that is shared between all the banks. The address of managing private keys. So this is something that is very specific to our development. That manages, if you want, wallets, because in our environment we cannot use MetaMask, but typically this would be replaced by MetaMask successfully. Where to connect to the blockchain node, the blockchain explorer. All right, so we save the configuration, and again, I'm not going to go into too much detail. I'm just going to keep an highlight view, and then I invite you to go to the prototype explanation and follow the steps and play with it. You will need to claim some token. So you can request that by going to the Carleano issues and request some tokens through the faucet. So this module is it's a very simplistic thing, but what it shows, and the idea is that several people can play with that application at the same time and represent different banks, obviously. So here I already have a bank back office module deployed on this address. And this is my wallet, my personal operator wallet, and I am the owner of that bank. Okay. In my bank system, I've got 15,010 euro available. So this is the cash that typically has been deposited to my bank, and that I have on my Nostro at the central bank. There is currently no debt. And here are other banks that I have registered and linked as correspondent bank typically. Okay. So if I have another bank that wants to enter in relation with me, I will sign an agreement with them and I can register the address of their smart contract to write the fact that we have a commercial relationship. Then we have the possibility to create bank accounts. So here we have client one that has been created an account with an IBAN, which is for the moment the standard IBAN mechanism of Ethereum, but it can be changed. So let's try to create a new account for our client. And let's say we create for client number 2. This will deploy the smart contract for the client, okay, through a factory. And the tool is actually asking me to sign the transaction. I'm not going to give up my password on this video, but you understand the principle. So this is submitting into the blockchain the creation of the smart contract for client number 2. It's empty, okay, because obviously it's an empty account that has been created. This smart contract is therefore created at that address and can be provided to my client. I am the owner of that account is actually the smart contract managing my bank. So if we look at 9446, it's actually the address of the back office module. Okay. Now, since I am the bank and, for instance, my client has sent me some money from an external bank account, so an account that is not on the blockchain, so maybe he already has an account with me on the conventional system and he's making a transfer, or he has made a Swift payment from another account, and let's say he sent me 20,000 euro on my account. So I can credit his account because I have received the money at my bank. Okay, so this is crediting an account with money that is coming from outside. So now if we look at the bank status, the total balance is now increased. Okay, so you have more money on my Nostro as the bank, and this money has been put on the client account. So obviously between those two accounts, we can do transfer within the same bank, okay, not with another bank. So let's say client 2 will be transferring 3,000 euro to this client 1. So I take the address of client 1 and put that in the target account. And that is making a transfer between those two addresses. And now the balance have been changed between the two addresses. And this page show the events that are happening. And here we have a transfer from client 2 to client 1 for a value of, here we have 300,000 because it's multiplied by 100 because there is no decimal stored on the blockchain. Okay, and now let's say client 1 wants to remove the balance on that account and send it elsewhere to another account. Then he sends us an instruction to transfer from that account to an external account, so we can't do it directly on the blockchain. So in that case, it's a debit. Let's say he wants to withdraw 10,000. So the back office will do a debit here, and then we'll use the money on the Nostro to transfer the balance to the target bank. So that's a very simple demonstration of the prototype, but there is more explanation in this documentation, and in particular, it's more interesting to test that between two banking environments, two banks, because when, let's say, client 2 wants to make a transfer, if the target account is an account of another bank, then it will do the interbanking system. So I'll let you play with that, and feel free to post some question and comments and things like that in the issue page. So thank you very much for following that video. I hope it has been clarifying what Socash is about, and we really look forward to your inspirational proposition on how to use Socash with Sobond in a DVP mechanism.